Last lesson, we learned about measures of center, specifically the mean and the median. Starting in this lesson, we're going to learn about ways that you can put a number or a measure to variability or spread. So we have two different styles of that, and they're broken up into this video and then the next one as well. So how can you measure spread in a data set? So in order to do that, our first way, this one you guys have actually heard of and used before, I assume, which is our first measure of spread, the range. To find the range of a data set, all you do is you take the maximum number, the biggest number, minus the minimum or the smallest number, and that's your range. Not very hard to do. A lot of times teachers will ask you mean, median, mode, and range. So you guys should have a little experience finding this already. So the trouble with the range is really it only involves two data points, the biggest number and the smallest number. Everything else means nothing when you're doing the range. So all those numbers in between sort of get thrown away. So it's not that great of a measure of spread in that sense. It's also not at all resistant to outliers. Again, bringing up my money example with good old Bill Gates, if I was going to have my numbers, this is our money right here. And I find the range right now, our range is 11 minus 1, which is 10. But if I add Bill Gates's number on the end of this, our range is like 99999, like really big number. Okay? Incidentally, one thing I will see somewhat frequently is kids will say the range is 1 to 11. That's not how you write range. You have to actually subtract biggest minus smallest. So is the range a resistant measure of spread as opposed to center? The answer is no. One outlier has a major effect, on the range because it becomes your new maximum or your new minimum. So the range is fine and good, but it's like kind of too simple to be of much use to us in statistics. So we need other options for calculating measures of spread. So what are quartiles, first of all? Quartiles are the 25%, the 50%, and the 75% marks of a data set. Basically, you break your data up into quarters. So you break your data into 4 chunks right there, and the mark for where each chunk begins is going to be the quartile marks. How do you find them? It's very similar to the median process. And when I say the median process, you put your numbers in order, and then you mark the middle. And actually, the median is the same thing as the 50% mark, or the second quartile in a data set. So when you have your 25, 50, and 75 percentile or percent marks right there, that's the first quartile, the second quartile mark, and the third quartile mark. So last video, I said we don't have a symbol we use a bunch for the median. We just usually write MED. I was kind of lying when I said that, because Q2 is the median. So you could say Q2 in place of median, but I see MED pretty frequently as well. So what is the interquartile range, abbreviated IQR? This might be new to you guys. The interquartile range has the basic definition in the title of it. Interquartile range is the range of the quartiles. So that is going to be your third quartile, Q3, minus your first quartile, Q1. IQR is the range of the quartiles instead of your overall range. Is the IQR a resistant measure of spread? The answer to that is yes. We will see that in our examples, but just like the median is resistant, IQR, which is based on position, is also going to be resistant to an outlier or two. So let's jump in with an example here. We are looking at a bunch of sandwiches at McDonald's, and we're looking for the median and the IQR. In order to do that, you first need to put your list of numbers in order from least to greatest. So I'm going to take the fat content of these sandwiches, and I'm going to rewrite them in order here. Oops, got a 14. So I got 9, 14, 16. Got a couple of 19s and then a 20. And then 22, 27, 33. So these are all of my different sandwiches right here. And then what I'm going to do to find the median. So the median comes first. That is going to be my middle number. 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 numbers. So the median is going to be this middle number right here. And when you put your list of numbers in order, I recommend actually drawing a line through the median. So my median in this first data set is a 19. So median is 19, and that's good. The next thing I'm going to do is find, so I found my middle mark in the data set. I'm going to take that lower half of numbers, and I'm going to find the median of those numbers right there. So I already crossed out my 19 right here. I'm not going to use that. I'm just going to look at these 4 numbers. The median of these 4 numbers is going to fall right there. 14 and 16, I would average those and get 15. That is the first quartile, or the 25% mark. So Q1 for this data set is a 15. And then I need to do Q3 the same way. I go to the upper half of my list, that being these numbers over here, and I calculate the median of those, which is going to fall right there at 24.5. So Q3 is 24.5. So to summarize what you got to do for this process here, it's not very hard to find the quartiles. You just do the median first. Then you take each half of the list and do the median of each of those, and those will be your Q1 and Q3 marks. So they asked me to find the median, did that, and they asked for the IQR. The IQR of this data set, interquartile range, is Q3 minus Q1. So I'm going to take 24.5 minus 15, which is 9.5 for your IQR. So your quartiles have a range of 9.5. Now I talked about how the IQR is actually resistant to outliers. Let's say I did tack on one more number, and I'm going to make it a low outlier this time. So if I had one more number over here, like a sandwich with 2, I don't know if that's an outlier or not, but one more number there. Now when I broke my list up, my middle would be right here. So I would have 2 middle numbers here, and I would add those up. My median would be 19 still. My Q1 would land right here and be a 14. And my Q3 would be a 22. So now my IQR would be 8 as opposed to 9.5. It did not change that much. So when you add a number on the end, the positioning shifts a little bit, but your IQR doesn't change nearly as much as the range would. So let's keep it going on to our next slide right here and talk about how you formally figure out outliers. So far in this class, what we've done is we've basically looked at a picture and been like, this feels like an outlier, or this doesn't seem like an outlier. And obviously we want to be more specific than that. There are specific methods out there, and there's not just one. We're only going to learn one in AP Stats, but there are different ways you can calculate outliers. One of the more popular methods for finding outliers is called the 1.5 times IQR rule, okay? So if you are more than 1.5 times the IQR away from the box, and that will make more sense later in this video when I show you what a box and whisker plot is. But what I mean by that is Q3 or Q1, you are an outlier. That will make more sense through example. So don't worry about that right now. Just have this written down. This is more for you to reference later on. But we're going to do calculations here and calculate mathematically if something is an outlier or not. So let's look at a new distribution here. So last time we were looking at like fish sandwiches and stuff. Now we're looking at the like hamburger style. So what I want to do first, actually, instead of finding the median and mean and stuff by hand, because that's kind of annoying, it takes a little bit of time, I'm going to show you guys how you can find them on the calculator. So you can save yourself a little bit of trouble and not have to do the whole process. So in order to do that, you're going to go stat edit. We use this menu a lot in this class, and type in your data set. Make sure when you type in your data set, you don't accidentally miss a digit, because even one missed digit is going to throw things off. Okay, and then once all your numbers are in there, you're going to quit out and go back to stats. In the stat menu, you go over to where it says calc, and the very first option here, which says one variable stats, is what you want. So you go stat, you go calc, you go one variable stats. L1 is the list I care about. I want frequency list to be blank. I'm going to hit calculate. And when I do that, the calculator spits out a whole bunch of stuff that it's calculated about our data set. We'll use some of this other stuff later, but I'll point out the mean X bar is 24.8 from that data set. If you keep on scrolling down, it's going to give you what's called a 5-number summary, which I define in like a slide or two. The 5-number summary is the minimum, each of your quartiles, Q1, Q2, Q3, and the maximum. So I'm going to go ahead and just copy down what I need shamelessly from this data set here. They asked, are there any outliers? Well, my Q1 is going to be 21, and my Q3 is 29. Okay, so Q1 is 21, Q3 is 29. You could also find that by hand, but I figured that was as good a chance as any to show you guys how to do this on the calculator. So the 1.5 times IQR rule says you got to find your IQR first. That's Q3 minus Q1. 29 minus 21 is 8. Then you take that value of 8 and you multiply it by 1.5. 1.5 times 8 is a 12. Why is it 1.5? Where did that even come from? No joke, the reason it's 1.5 is the guy who made this felt that 2 was going to be too much, that was a little too big, and 1 was not big enough. So he's like, hey, 1.5. Sometimes statistics is like that, where it's just like, it feels like a good idea to do that. There are other methods for finding outliers that we will not talk about in EP stats, but they do exist. So don't feel like this is the only way to do it. It's the only way you'll have to do it when I ask for it. So this is 1.5 times the IQR. If you are farther than 12 away from Q1 or Q3, you are an outlier. So let me show you how that works. I'm going to take my Q1 first. Q1, and I'm going to go down by 12. 21 minus 12 is 9. So if you are lower than 9, you're farther than 12 away, you are an outlier. You'll notice I have an actual data point that is 9. That is not considered an outlier. It has to be farther than that. And then I'm going to go to the high end of this distribution. So the high end Q3 is 29. And if I add 12 onto that, I am going to get 29 and 12 is 41. So if you are bigger than a 41, you are also an outlier. So you take Q1, Q1, and you take Q3, and you go up or down by that 1.5 times IQR. This is like my safe window. If you are in this range right here, you're not an outlier. You're close enough to the bulk of the data points where you're good to go. If you are smaller than 9 or bigger than 41, you went too far away and you are an outlier. So in this data set, we do have an outlier of 43. He was too big for my number list right there. So the number 43 is an outlier. The biggest mistake I see kids make on these problems, and I kind of almost don't want to say it to put it in your head, but people will use the median mistakenly instead of Q1 and Q3 when they do this calculation. So you go from Q1 and Q3, which are the edges of the box in a box and whisker, which I'm about to show you how to make. So that is how you calculate an outlier mathematically. So let's go ahead and keep it moving here. So we are going to write down the 5-number summary for both data sets. 5-number summary, again, is going to be your minimum, your Q1, Q2, Q3, and your maximum. And you can do this by hand. This first data set we already did, and then the second one I had on the calculator, but I didn't write everything down. So I'm just going to write down those things again. And I'll pause the video and get those written down for you guys. Okay, so I'm back. I ended up putting both of them over on the side and moving to the next slide right here. So you have your 5-number summary for fish and for beef, and you can get that by hand or using your calculator. Either way is totally fine. We are going to use the 5-number summaries here to make box plots, also called box and whisker plots, for our data sets. So in order to make a box and whisker plot, you need to know the 5-number summary. The 5-number summary is what you need to make a box and whisker plot. And I'm going to start out with the fish and chicken example, which is right here, which did not have any outliers in it. So what I'm going to do is I'm going to put 5 lines on my little, I have a number line going on right here, and I'm going to stack these on top of each other. Little line right here for that'll end up being the minimum. Then I'm going to do bigger line for the Q1, bigger line for Q2, bigger line for Q3, and then smaller line for maximum. So what happens is your 3 big lines, Q1, Q2, Q3, make up the box in a box and whisker plot. So I'm going to connect those into a box, and then the little whiskers reach to the minimum and to the maximum. So that's actually a pretty decent looking box and whisker plot. A little wobbly, I guess. But that's what's going on. When you look at a box and whisker plot, you cannot see the mean. Later, I'll talk about the mean with regards to pictures. People will say, oh, the mean is this. You can't see that in a box and whisker. What it does for you is it shows you the minimum, the maximum, and then Q1, Q2, Q3. So if you know where Q1, Q2, Q3 are, the middle 50% of your data is between Q1 and Q3. It's inside the box. So 50% of your data lives here. And basically, your picture is broken up into 4 little segments, each with 25% of the data. 25% of points are here to here, 25 here, 25 here, and then 25 here as well. All right. Sometimes you'll see like it's kind of helpful if you put like, oh, this is 9, this is 15, but I already have a number line here and I have it written, so I'm not going to bother. Okay, there is one difference that you have to consider when you have outliers in your data sets. So let me show you how that works for the beef example. There was no outlier on the low end. It was still just going to be a 9 right there. So little mark, my big mark was 21. Then I had 26. I should have made these the same height, so I'm going to go erase a little bit of that. So I got 21. Then 26, and then 29. So my picture is maybe a tiny bit sloppy here. Now on the big end of the picture, I do not go to 43 because 43 was an outlier. I need to go to the biggest number that was not the 43. So the biggest number that's not an outlier in this data set is 31. That 43 is kind of crazy. It's a big difference. But yeah, 31 is my next biggest number. So that is where my whisker goes to. The whisker reaches to the biggest number that is not an outlier. So 31, I just said, is going to get a little line for the maximum. There's my box. I reach to here, and then I reach to here. And outliers on a box and whisker plot appear as single dots off of the picture. So they're not connected. So there's an outlier right there. So you can look at that and right away know, oh yeah, that 43 is an outlier. All right, it says to compare the distributions. When you talk about shape, and I'm not gonna write out a whole thing for this like we've been doing, but you would talk about the distribution of grams of fat in fish and chicken sandwiches is, look at the direction that your picture is being pulled. This picture right here appears to be stretched. So I'm looking first at the red one. The red picture is skewed to the left. It's being stretched this way. And pay more attention to the tail than you do to the box. So if you have one giant tail, like this is a left skewed distribution here, but it's being stretched in that direction. The green graph, on the other hand, seems somewhat symmetric. You could argue this tail is a little longer than this one, so maybe it's a slight skew to the right. So a slight skew to the right or roughly symmetric could both be acceptable answers for this one. Okay, so that would be shape. Center, you're going to talk about the median. Kids get burned on this because they talk about the mean. You can't tell the mean by looking at a box and whisker. The median for beef is greater than the median for fish and chicken, and you know what the medians are. You have them right here. Okay? Outliers, when you talk about that, there is an outlier here. There's no apparent outliers in this distribution. And then spread is, you could talk about for spread a lot of things. You could do the straight up range. You could do the range, but like discounting the outliers, or you could talk about IQR. Any of those would be acceptable ways of talking about range. I'm going to go with IQR right here. The IQR for the fish actually is a little bit bigger or more variable than that of the beef. It was like 9.5 versus 8, it looks like. So doing socks on box and whisker plots is not that bad. The last thing I need to do in this video is show you guys how you graph box and whiskers on the calculator, and I'll spare you watching me type it all out. I went stat edits, and I already have my numbers for the beef in the first one right here. It doesn't really matter which one goes in which list right now. So I'm just going to keep that, and then I'm going to type in my fish numbers as well. So if I do that, I'm probably not going to bother pausing because it won't take that long since I have one list already. You just type your numbers in L1 and L2. Again, doesn't matter. My beef is L1, my fish is L2, but you could have it reversed. It's not a big deal. 20, 14, and 19. Once your lists of numbers are in the calculator, what you're going to do is quit out like we've done before. You're going to go second y equals. And this time I'm going to have a plot 1 and a plot 2 because I have 2 data sets. I'm going to go here and I'm going to scroll and choose the box and whisker with dots on it. That's for an outlier version. This other version here disregards outliers and pretends like they're just normal points. So you always want to choose the outlier version. I've got L1 for my first one, frequency, that's fine. I'm going to go back now to second y equals, and I'm going to turn on my second graph as well. In my second graph, I'm going to also do a box and whisker with outliers. This time though, my list of numbers is not L1. I already did that. It's L2. To get L2, I just hit second 2, and it makes it say L2, and they're both in there. Now I'm going to graph it. I don't really see much. So remember, you go zoom stat, zoom 9, and if you do that, it'll show you both box and whisker plots. So that should look familiar. We have the fish one on the bottom. We have the beef one up top. There's my outlier. Sort of symmetric looking right here, skewed left over here. And the cool thing about this, if you already graphed them, if you hit trace, it'll zip around and it'll show you your 5-number summary plus outliers. So it's kind of a handy way that you can go ahead and graph these. If I ask you to graph a box and whisker, I don't need, on a quiz or something, I don't need you to do it by hand. You can very easily throw it in the calculator and then just get your 5-number summary, get your outliers by looking at your graph.